Have you ever pondered about how much water is hidden within the Earth's crust beneath our very feet? It's a fascinating concept, isn't it? When we think about water on Earth, our minds immediately picture the vast oceans, winding rivers, and serene lakes. But that's not the whole story. There's a hidden watery secret that our planet holds, a secret that lies beneath the surface in the very rocks that make up the Earth's crust. See, our planet's crust isn't just a dry, rocky layer, it's more like a sponge, teeming with water in its pores and mineral structures. This water is not locked away in underground lakes or rivers, but it's bound within the rock itself, in the form of hydroxyl groups attached to mineral crystals. It's not as straightforward as it may seem, but that's what makes it all the more intriguing. So the next question arises, how does the water get into the Earth's crust? Water doesn't just magically appear in the Earth's crust, it's a fascinating scientific process. Imagine the Earth as a vast, dynamic system where tectonic plates dance and glide across the planet's surface. These plates, composed of the Earth's outermost layer, the crust, and the uppermost part of the mantle, are in constant motion. As they move, they interact in various ways, creating what we know as plate tectonics. One such interaction, called subduction, plays a crucial role in the journey of water into the Earth's crust. In subduction, an oceanic plate collides with another plate and, being denser, is forced beneath it, plunging into the mantle. This process isn't just a display of Earth's geologic might. It's a vital part of our planet's water recycling system. As the oceanic plate descends, it carries with it water from the ocean. The water is not just in the form of liquid, but also trapped in the structures of minerals within the plate. This is where the process of hydration and dehydration of minerals comes into play. Hydration is when water molecules integrate into the mineral structure, while dehydration is the opposite, with water molecules being expelled from the mineral structure. As the subducting plate sinks deeper into the Earth and encounters higher temperatures and pressures, dehydration occurs. The expelled water rises, contributing to the formation of magma and eventually making its way back to the surface through volcanic activity. This cycle is a vital part of the Earth's water balance. The water expelled from the minerals doesn't just vanish, it contributes to the formation of new crust, gets recycled back into the oceans, or becomes part of the Earth's vast reservoir of hidden or crustal water. And it's not just a drop or two. The amount of water stored in the Earth's crust is substantial, locked away in rocks and minerals beneath our feet. Now that we have understood the process, let's delve into the quantity of this hidden water. So, how much water are we really talking about here within the Earth's crust? Well, to put it into perspective, imagine the volume of the world's oceans. But instead of the vast blue expanse stretching out under the sky, that water is concealed within the very rocks beneath our feet. Scientists have estimated that the amount of water in the Earth's crust could range from the equivalent of one ocean to nearly 3 times that amount. That's right, there could be up to 3 oceans worth of water hidden within our planet's crust. Now you might be wondering, how do scientists come up with these estimates? The answer lies in the field of geology, a science that delves deep into the Earth's structure. By studying the composition of rocks and minerals, geologists can make educated guesses about the amount of water they contain. But it's not as simple as it sounds. The Earth's crust is not a uniform layer. It varies in thickness, composition, and temperature, all of which can affect the amount of water it holds. This complexity makes it challenging to calculate an exact amount of water in the crust. For instance, consider a type of rock called basalt, which forms the oceanic crust. It can contain up to about 0.5% of its weight in water, but the continental crust, composed mainly of granite, can hold up to 4%. Then there's the factor of depth. The deeper you go, the more pressure there is, and under high pressures, some minerals can hold more water. So, with all these variables, it's no wonder that the estimated amount of water in the Earth's crust is such a wide range. But regardless of the exact figure, one thing is certain. This hidden water is more than just a geological curiosity. It's a key player in the Earth's geological activities, influencing everything from the formation of minerals to the movement of tectonic plates. The exact amount may be a mystery, but the presence of this water plays a critical role in our planet's geological activities. We've uncovered the Earth's watery secret, but why does it matter, you might ask? Well, the water within our planet's crust isn't just idle moisture, it's a dynamic force that impacts the Earth in remarkable ways. Let's start with seismic activity. The presence of water in the Earth's crust can alter how seismic waves travel through the Earth. When water is present, rocks become more pliable and less prone to sudden catastrophic breakage. This can mitigate the severity of earthquakes, making them less destructive. In essence, water acts like a geological shock absorber, dampening seismic violence. Moving on to the formation of rocks. Water plays a critical role in the creation of certain types of rocks. When crustal water reacts with magma, it triggers the formation of minerals and igneous rocks. It's water that helps transform molten rock into the diverse array of stones we see today, from granite to basalt. So without the water within our crust, our Earth's surface would look drastically different. Now let's talk about something even more surprising: the Earth's magnetic field. Water in the Earth's crust contributes to the creation of our protective magnetic shield. When water interacts with minerals in the Earth's mantle, it aids in the generation of electric currents, which in turn helps to create and sustain our magnetic field. This magnetic field is crucial as it protects us from harmful solar radiation, so there you have it. The water hidden within the Earth's crust is no ordinary water. It's a seismic moderator, a rock creator, and a magnetic field generator. Crustal water, though concealed from our sight, plays a vital role in shaping the world we live in. So, the next time you sip on a glass of water, remember you're partaking in a geological marvel that runs deep beneath our feet, shaping our world in ways more than one.